Could the human race ever switch off a hurricane? Could we power an entire planet without burning a single thing? Could a species like ours light up not just a city, but a whole world? And if we could, where does it stop? Is there a limit to how powerful we are allowed to get? Because right now, everything we have ever built runs on almost nothing at all. Scientists actually drew a ladder for this, one that measures how powerful any civilization in the universe could ever become. And us? We have not even made it off the bottom rung. To see how far this ladder goes, you have to look up, because the gap between flicking on your bedroom light and holding the power of an entire star is bigger than you could possibly imagine. And believe it or not, one day, that star could be ours. But let us start where we really are today. Add up everything humanity builds and burns, all at once. The whole species runs on about 20 trillion watts. It sounds enormous. It is almost nothing. Because the sunlight hitting the top of our sky, every second, is nearly 200,000 trillion watts. The light landing free on our doorstep is about 8,000 times everything we use, and we catch almost none of it. Enough sunlight falls on Earth in a single hour to run the whole world for a year. Most of it just warms the sand, and that is only the thin sliver that Earth happens to stand in front of. For every 2 billion rays the sun throws out, we catch one. The rest pours into empty space, forever. One man turned all that waste into a way of ranking entire civilizations. In 1964, a Soviet astronomer, Nikolai Kardashev, was hunting for alien signals. To find one, he first had to guess how powerful a civilization could possibly be. And it all came down to one brutal number. Not weapons, not cities, energy. So he sorted every civilization that could exist into three kinds. A Type 1 commands the power of a whole planet. A Type 2 commands the power of an entire star. And a Type 3 commands the power of an entire galaxy. And each step up is not double or 100 times. It is 10 billion times more powerful than the last. Climbing a single rung is the difference between a candle and a whole country. One thing to be clear about first. This is a way of thinking, not a law of nature. Kardashev simply drew a line through the fog. It just turned out to be useful. So, rung 1. A Type 1 civilization owns every drop of its planet's energy, every ray of sun, every wind, every wave, the heat under every volcano, which means something staggering. A civilization that could steer a hurricane, end a drought, and shrug off an earthquake. Today, when those things come, all we can do is run. But Kardashev's scale had only 3 steps, a bit like a ruler with just 3 marks on it. Carl Sagan thought that was far too blunt for a species like ours. So he wrote a formula that turned 3 giant steps into one smooth slope, so that any civilization could be given a score. Then he worked out ours. Humanity came out at 0.7. Not most of the way up. 0.7 at the very foot of the climb. Half a century later, after all our growth, we have crept to about 0.73. To stand as a full Type 1, we would need 500 times the power we make today. Take that gently. It is an estimate, run differently by different people, from about 0.7 to 0.75. The exact number does not matter. The distance does, and the distance is almost unimaginable. So what would 500 times actually look like? Not spaceships, not magic. Mostly, it would look like deserts. The Sahara alone drinks more sunlight in a year than all of humanity uses. Blanket a serious share of the world's deserts and collectors, and you could stop burning things entirely. And then there is the other half of the climb, fusion. Squeezing hydrogen until it becomes helium, which is exactly what the sun does above your head. The fuel is seawater. Fusion has been 30 years away for about 70 years now. But in December 2022, something finally changed. A lab in California fired 192 lasers at a fuel pellet the size of a peppercorn, and got more energy out than went in. Barely. For an instant. But the door came open. Say we manage all of it, and we would be Type 1 at last. A civilization that never has to ration power again, that could green a desert or pull a city's water straight out of the sea. And we would still be on the lowest rung, staring up at the thing that has been wasting its power the whole time. Our sun throws away 2 billion times the energy Earth catches, into darkness where nothing will ever use it. In 1960, a physicist named Freeman Dyson asked a simple, dangerous question. What if a civilization just stopped letting the light escape? Borrowing an idea from a novel written in 1937, he imagined an old civilization wrapping its whole star in collectors. A sphere, sealed around a sun. The solid version would tear itself apart. That was never really his idea. What he pictured was a swarm. Countless separate collectors, thickening around the star like dust in a sunbeam. But to build a swarm, you need material, planet-sized amounts of it. Which leads to a sentence most people have to read twice. You take a planet apart. The usual candidate is Mercury. Small, close to the sun, no life, and full of metal. 2 researchers at Oxford ran the numbers. Solar-powered miners that build more miners. Their answer? 31 years and 85 days to dismantle the entire planet. Not because the machines are fast, because they double. Each one builds the next, until where Mercury used to be, there is nothing at all. And around the sun, a slow black glitter of trillions of panels, drinking nearly all of a star's power. Energy enough to light every world around it. To move planets, to run a civilization for 1 billion years. From far away, that star would look like it was quietly going out. And that detail is the one that matters most. because it means we can go outside and look for one. Energy never simply vanishes. Whatever you do with starlight, it ends up as heat. And heat leaks away as infrared, the invisible glow you feel off a radiator in a dark room. You cannot hide it, so a star wrapped in collectors would look wrong. Too dim in ordinary light, glowing far too warm in infrared. Dyson's real idea was never to build one of these. It was to search the sky for somebody else's. For 55 years, nobody found a thing. Then one star, 1,500 light-years away, began behaving impossibly. The Kepler telescope had been watching thousands of stars for the tiny dip when a planet crosses in front. And ordinary volunteers, scanning the data at home, flagged one star as deeply strange. We call it Tabby's star. What those volunteers had found were dips. Enormous, ragged, irregular dips. A giant planet crossing a star blocks about 1% of its light, like clockwork. This star dropped by 22%. No rhythm, no pattern, nothing that shape should exist. The astronomer Tabby went through every natural explanation. Not one of them fit. And then an astronomer named Jason Wright wrote down the other possibility. Cautious, hedged, but there in print. The dips looked like a swarm of huge structures, halfway through being built. And for a few weeks, serious scientists genuinely wondered if we were watching a Type 2 civilization switch itself on. Radio telescopes swung toward it. A great many people held still and listened. Nothing came back, no signal, at any frequency they tried. And then the real answer arrived from a far duller direction. They caught the star dimming again, in several colors at once, and it swallowed more blue light than red. A solid object, a panel, a wall, would block every color the same. Only something tiny blocks them unevenly. Dust. A vast fine cloud of it, drifting around the star. So the megastructure was ruled out. And it was never really proof of anything. It was an honest hole in our understanding, and a few scientists brave enough to say the quiet possibility out loud. But the search did not stop there, because if a swarm around one star is hard to spot, a whole galaxy full of them should be impossible to miss. That is Type 3. One civilization, harvesting hundreds of billions of stars, its whole galaxy rebuilt into a machine. Something that could cross between the stars as easily as we cross a street, and outlive the death of worlds. And a galaxy used that way would glow in infrared, like a stove left on. Which means we can check. So a team at Penn State did exactly that. Using an infrared survey of the sky, they examined 100,000 galaxies, looking for any that burned warmer than their own starlight could ever explain. 50 looked a little odd, but not one showed a civilization feeding on its galaxy. 100,000 searched. Nobody home. Which brings us to a very old and very uncomfortable question. In 1950, over lunch, the physicist Enrico Fermi stopped mid-sentence and asked it, "Where is everybody?" The universe is nearly 14 billion years old. There has been time, over and over, for someone to climb this ladder before us. And when we look for the heat they would leave behind, we find a clean, quiet, empty sky. There are only a few honest answers to that silence. Maybe nobody is out there. Or maybe they climbed and simply chose never to devour their stars. Or maybe something waits on the ladder that nobody ever gets past. That last idea is only a hypothesis, with no evidence behind it. But it points straight back at us. Because many of the dangers we now fear appeared in the very same century we began to climb. So here is where we honestly stand. 0.73. A species that still warms itself by setting fire to things. We cannot steer a storm. We cannot end a drought. We have not taken the first real step. We are still deciding whether to. And tonight, you will flick that switch, and the room will light up. And out past the window, a star will be pouring 2 billion times the energy Earth catches into empty space. Waiting. Physics says we could, one day, reach up and take it. The only question is whether we last long enough to try.